Hello, everyone. My name is Johnny Vu, and welcome back to week 11. Today, we'll be talking about IDEs and AI, specifically how we can integrate AI with our IDEs in order to boost productivity, and also along with how it can change the role of software developers in the future. So, to start off, we'll be talking about AI prompting. One of the foundational tips is to be incredibly specific about technologies or approaches you want the AI to use. For instance, instead of a vague request, specify languages like JavaScript and Python, or frameworks like React and Tailwind CSS. By doing this, you ensure that the generated code aligns with your existing project and your own familiarity, making iteration much smoother. Moreover, specifying technologies can signal to the AI that you have technical understanding, often leading to a higher quality output. Before you even write a prompt, take time to design your solution. Don't just give the AI an open-ended request. For example, if you want to add a search feature to a product list, think through the specifics. Should it be searched should it search by title, description, or both? Are there any filters needed? Should there be sorting capabilities? Breaking down your request into specific tasks can significantly improve the AI's ability to understand and implement features correctly. Instead of asking to build a search feature, you might say, build a search feature that 1. Searches for product titles and descriptions, 2. Allows filtering by product type, 3. Includes an option to sort results by price. Finding the right balance in the scope of work you give AI is also key. Asking for very small snippets might lead to slow progress and excessive iteration, while asking for an entire application at once is unrealistic. Experience will guide you in determining the optimal amount of work for each prompt. Finally, using examples in your prompts can be incredibly effective. If you want a function to format dates in a specific way, provide examples of the desired input and output is often clearer than just describing every possible edge case. You can even provide snippets of existing working code for the AI build upon or integrate with. Moving on to the next slide, we can talk about AI-powered integrated development environments, or for short, we can call them IDEs. These tools embed AI capabilities directly into the coding environment, going beyond simple and autocomplete features. Two prominent examples we see discussed are Cursor and Windsurf. It offers features like AI chat panels integrated into the editor, allowing the AI to be aware of your project files and make changes across them. Cursor has different modes, with agent mode being designed for making changes to your code autom- autonomously. On the other hand, we have Windsurf, which emphasizes agentic coding agents that streamline coding workflows, generate and modify code across multiple files, and enhance development efficiency. And we can also see from their philosophy that their trajectories read your mind with deep integration of AI agents into the editors. Features like Continue My Work and automatic terminal execution showcase this more deeply and integrated approach. When choosing an AI ADE, consider the factors like coding generation accuracy, natural language understanding, multi-file editing capabilities, and development speed. The agentic nature of these tools, their ability to perform tasks autonomously across multiple files, is a significant advantage over traditional chatbots. A critical aspect of successful AI assisted coding is context management, or we can call this the golden rule of coding with AI. Giving the AI enough relevant context is crucial for it to understand your existing codebase and write new code that integrates seamlessly. If you don't provide enough context, the AI might make inaccurate assumptions leading to code that doesn't work with your existing software. Conversely, providing too much context, such as an entire 5,000 line file, can be problematic, potentially confusing the AI, leading to code deletion or duplication. Therefore, finding the right balance is essential. One powerful technique for managing context is tagging specific files relevant to your current task. In Cursor, you can use the @ symbol to tag files you want for the AI to consider. Similarly, Windsurf allows you to reference specific files or directories. This focused approach helps direct the AI and ensures it's working with the necessary information. It's also important to be mindful of your conversation history. Each message in your chat becomes part of the context for subsequent requests over long conversations. And the AI might get confused or start referencing outdated information. A good practice is to start a new conversation when working on a new feature that isn't directly related to the previous task. You can always reference parts of earlier conversations if needed, but a fresh start can prevent confusion. Both Cursor and Windsurf offer additional ways to provide context. You can often tag official documentation or provide web links for the AI to reference. Cursor even allows you to include images as visual context. Windsurf takes context management a step further with auto-generated memories, where the AI learns your preferences, technologies you use, and even your project architecture over time, reducing the need for repetitive prompting. When it comes to ensuring the quality and stability of your code, AI can be a valuable ally in testing and debugging. We can proactively ask the AI about potential security vulnerabilities and the efficiency of its own code. You can do this in your initial prompt or as a follow up prompt after the feature is implemented. Furthermore, you can directly ask the AI to review your own code. While you should always review the code yourself, AI can provide an initial pass highlighting potential issues for improvement. We we can also ask the AI what the current code does and how it works, as this can often reveal things you might have missed and provide a better understanding of the codebase. For a more proactive approach, consider the test-driven development, where the AI writes the test before implementing the feature. This can particularly if this can be particularly effective with AI agents, allowing them to iteratively write tests, build the features, then ensure that it passes all the tests, even handling edge cases. When you inevitably encounter bugs, being specific about what's going on is crucial for effective troubleshooting with AI. Share details about the code, about where the code works and where it fails, and provide as much context as possible. Copy pasting error messages directly into the AI can often quickly pinpoint the problem. You can even use the Beaver method, asking the AI to insert logs into your code to gain a deeper understanding into the execution flow. Sharing these logs with AIs can help it identify the exact point where things go wrong. Sometimes you might find yourself stuck in a troubleshooting loop. In such cases, in such cases, we can try asking the AI to try radically something different, uh, and which it can force it sometimes to step back and explore entirely new approaches, often leading to a breakthrough. However, it's also vital to know when to pause the AI and dig into the code yourself. Finally, we can consider how AI is influencing the role of developers and how we can leverage it for learning. Asking the AI to explain code line by line or add comments can significantly aid in understanding syntax or complex coding patterns. Beyond code itself, you can use AI to learn about specific vocabulary, technologies, and software concepts. Asking, how would you build something, can provide valuable insights into architectural considerations. As we've seen, AI can handle significant portions of code generation, this leading to the shift in the developer's role. Founders surveyed by Y Combinator are reporting a transition towards product engineer roles, where human taste and understanding users needs to be more critical. There's also a continued need for architects who can solve complex system problems, an area where AI tools are not as strong yet. Despite the advancements in AI coding tools, debugging remains a crucial human skill. The Y Combinator survey highlighted that current AI is often terrible at debugging, requiring explicit instructions and human intuition. Therefore, developing your ability to read code and identify issues is more important than ever. The concept of vibe coding was popularized by Andrej Karpathy, which reflects a new reality where rapid iteration and experimentation powered by AI becomes the norm. With AI making code generation significantly faster, developers can be less attached to their code and be more willing to scrap and rewrite when necessary. This leads to increased productivity and a faster pace of development. However, while AI is an incredible tool, there is no world where you can just vibe code an entire project. Human oversight, understanding, and the ability to step in and solve complex problems manually remain essential. what can we conclude from all of this? Ultimately, AI coding is not about replacing developers. It's about augmenting their abilities, freeing them from repetitive tasks, and allowing them to focus on higher level problem solving and innovation. By embracing these tools and understanding of their strengths and limitations, we can use these to possibly make things just a lot easier in the future and hopefully not abuse them in the case of vibe coding. Thanks for listening.